This is triple award. This is the first reversible reaction I'm going to show you. Now, you're all familiar with copper sulfate. We've got copper sulfate in a boiling tube with a stopper and a delivery tube coming into an empty boiling tube in a beaker of cold water. So the delivery tube comes into the boiling tube. I've got a Bunsen burner under here. I'm going to light the Bunsen. And what's going to happen is the blue copper sulfate is going to start turning white. And I'm hoping you're going to start seeing that on the screen. You can see the edges now starting to turn white of the copper sulfate, and there should be some condensation in the tube as well. Now, because I'm applying heat to this copper sulfate, this is an endothermic because it needs heat to remove the water, because you can see the condensation in the tube here, and that's what's going to happen in this boiling tube. The water vapour is going to condense so that it comes out of the delivery tube. That's why it's in a beaker of cold water. Now you can see that the copper sulfate is turning white. So hydrated copper sulfate, which is blue, will turn white when you heat it because it loses water. Okay, so I've got my anhydrous copper sulfate, the blue copper sulfate that I heated up previously. I've removed all the water from it, and it's now a white powder. So it goes from blue crystals to a white powder once it's lost water. And just that it's a reversible reaction. If I add paraffin to the anhydrous copper sulfate, you can see no change, nothing happens. Whereas if I add water back onto the anhydrous copper sulfate, it turns blue because now the water molecules are adding back to the crystals. It's also getting warm. The bottom of this dish is warm because it's an exothermic reaction. Remember last time when I was adding heat to it, I was putting heat into it, it was endothermic. This is exothermic because it's releasing heat. And you can see that it's turned back blue. Nothing happens with the paraffin.